The first important question we have to ask is, what is chemistry? Maybe bigger picture, what is science? So chemistry is the study of matter and its changes. Anytime we're studying the properties, behavior of matter, we're studying chemistry. Anytime we're looking at the way matter changes, we're studying chemistry. So what is matter? Matter is anything that has mass and occupies space. Matter is stuff. What about changes? Changes are rearrangements of matter on either a macroscopic or a microscopic scale. We're going to talk about macroscopic and microscopic a lot. Macroscopic is the scale that you can pick up and hold, right? Microscopic is not necessarily what we would think of in like just a microscope that you would use, but when we're talking about the microscopic scale of matter, we're talking about all the way down to atoms, molecules, and the individual pieces that make up matter throughout. Science itself is really more of a method. It's not a thing, it's an approach. It's a way to advance knowledge. So science is usually thought of as the process of making observations, based on those observations, performing tests, and then developing a model or developing some way that we can understand our observations based on more observations. There are a lot of different fields of science. Chemistry is often, by chemists at least, called the central science. So when chemists draw a picture like this, we tend to put chemistry right in the middle because we think that chemistry is the most important part of all of the sciences, and everything else kind of radiates out from that. When we're using the scientific method to approach knowledge, there are some fairly well-defined steps, but really every scientific exploration begins with curiosity. You observe something and you think to yourself, I wonder why that happened. What can you do to explore why that happened? Well, if we're following a scientific method, one of the first things that we do is make that observation and then propose a hypothesis. A hypothesis is just an idea of why something might happen. Once we propose that hypothesis, we need to go back and test that hypothesis with an experiment. So we develop experiments that test the hypothesis, but an experiment is really just an observation. So as soon as we develop and do that experiment, we jump right back here to an observation that now informs our hypothesis. Was the hypothesis true? Was the hypothesis not true? Was the hypothesis sort of true and needs to be adjusted a little bit? So the scientific method is cyclic. It's an iterative process we work through over and over again to try to advance knowledge. That brings up, of course, the question of what's not science. Well, science really focuses in on that hypothesis. And in order to be a good scientific hypothesis, it has to be both testable and falsifiable. So a testable hypothesis is something that we can test with an experiment that gives us directly observable results. So we don't want a hypothesis that we just have to have a feeling about. We want directly observable results. Falsifiable means that we need to develop our hypothesis in a way that it can be false, and it can be shown to be false. So science in general doesn't really prove things are true. It eliminates as many of the false things as possible so that whatever we're left with must be the most reasonable explanation for something. And just as a note, sometimes science and non-science feud a little bit about which one is better, which one is good, which one is right. If something's not science, it doesn't mean that it's necessarily not good, not right, but it's just not science. There are different ways to approach things. Probably the most common one that people run into here is faith. Faith is not science, and that's okay. It's just a different way of prioritizing things. Well, there is chemistry and the nature of science. We'll get on to the next video.